math will always hold. You'll use X plus or minus whatever was in storage. And the only thing that will change so that those numbers can be balanced is the price. And oil is like any other commodity dealt with in the free market. The price adjusts such that supply and demand intersect. And that's economics 101. And they will always intersect. You will not use more than what is produced. If something's scarce, the price goes up. And that, I think, to some extent, is what we've seen happening. There are other effects going on. I will admit that. There's obviously speculation, but that can work both ways. And just as people were saying there was speculation to drive the price up to $147 a barrel, there may be speculation now that's driving it to a lower number, and so that can cut both ways. Well, let's look at the implications of all this. First of all, both discovery and production follow a bell curve. You start out, you're not very good at this business of finding oil, and you get better and better, and you find more and more. But meanwhile, people are digging it out of the ground, so it's like picking the cherries off the tree. At some point, there's not as much to find, and so your discovery starts to drop off. So it does go through this cycle. It rises, and it, as I mentioned before, reached a peak in 1930 and for the United States. And then you go 40 years later, and you find that production had reached a peak. That 40-year lag seems to be a reasonable number, not just for the United States, but when we look at individual oil fields in other countries. And as I mentioned, the world oil discovery peaked in 1965. Now, those of you that are really good at math can take 1965 and you can add 40 years, and you see that you're approximately at the present time. So that's one indication that we may be at peak oil. The mathematical methods of Hubert are indicating that as well. A lot of people have denied the existence of peak oil. I can understand that. Oil companies don't want to feel that they're in a business that's on the way down. So there's a lot of psychology. However, I've said to some people who are bothered by this, I said, well, don't worry, because oil peak means flow in terms of barrels per day or barrels per year. And the dollar peak, that's going to come in the future. We're not there yet. The dollars are yet to peak. So that's the good news for the oil people. Any oil people here? No, okay. Well, and as I mentioned before, economics of scarcity can be profitable, and so that's something to keep in mind. What the oil companies are not worried about is scarcity. Scarcity can be profitable. I think what they're worried about is you guys, alternatives. Because if, for instance, you were out in the desert and you were the only guy that had a well with water, as that well got drier, you might be getting richer because, people are thirsty and they're dying of thirst and you're taking their life savings away from them. But your big problem would be if somebody came along with, Coca-Cola or something like that or 7-Up. The alternative to water would be your big problem. And I think the alternative, viable alternative to oil is the biggest threat, not scarcity of oil to the oil companies. Well, enough about oil. I've got to move on. Global warming, some observations, scientific predictions, incomplete knowledge, belief systems and biases. I'll try to touch on all of these. Let's look at observations. At 1968, the average temperature of planet Earth, and the data that I get has an extra decimal point, but I didn't put it in, 13.9 degrees C. And then we go 40 years later, 14.8 degrees C, which means the temperature is rising at a rate of a 50th of a degree C per year. That doesn't sound a lot to human beings or other creatures because we live, lifetimes that are relatively short. In geological terms, this is an extremely fast rate of rise. And it is, as we'll be discussing, having implications. What do we see that we generally can all agree on? And one of these things is the disappearance of ice. We're seeing ice surface disappear from the planet at a rate of about 1% per decade, and that rate is accelerating. The September ice cover is falling by about 100,000 square kilometers per year. So that's consistent roughly with that 1% per decade. And that, again, for humans that live only a few years, that may sound like a short time, but that's an incredibly rapid change for something that is on a planetary scale. More observations. By burning coal, oil, and natural gas, we're emitting 37 billion tons of CO2 per year. People who study it, there's no problem. These things are easy to come by. The residence time, the time that CO2 stays in the air, is quite long. It's about 90 years, and when it leaves the air, it ends up in the ocean, possibly some of it in the land. This is what is so different about global warming than conventional air pollution. With smog, if you stopped running the cars in Los Angeles in 1965, if you stopped running them for a week, you'd already notice a difference. With this, the stuff that we've done and our forefathers have done remains in the atmosphere for generations. So the time constants of CO2 residence is quite different than the time constants of other emission products. Since 1900, the CO2 has increased from 280 to 377 parts per million. This is very simple, solid stuff. We have many ways of verifying this, including samples of CO2 obtained from ice in the Antarctic. And it's also very consistent with the amount that we know we're putting up there. If you add the coal and the oil and the natural gas and the deforesting, the numbers are consistent. As a matter of fact, we do know that some of the CO2 we're putting in is going some other place, but the numbers fit together fairly well. The greenhouse physics, what is that? That's the physics which deals with the idea of sunlight being able to, the solar energy being able to come down very easily. It's in the short wavelength portion. And then when it gets down and strikes the Earth and other things, that energy has to go back out in order for there to be equilibrium, but now it's long wavelengths. And in the long wavelengths, the infrared, the atmosphere is no longer so transparent. And there are things that block the transmission of light back to space, or the transmission of electromagnetic radiation. CO2 is one of them, but another greenhouse gas is water. The difference between CO2 and water is water can easily come out of the atmosphere. It precipitates out. So if you put more in, it'll quickly reestablish an equilibrium and go out, whereas CO2 doesn't do that. The most calculations, if you do back of the envelope calculations, in connection with today's talk, I was doing some of this. You come out with temperature rises for the planet that actually are a lot smaller than what is being observed. And you realize that it's not, these calculations, in fact, are not simple. There's a lot of things going on. There's some things that are actually reducing the temperature rise. For instance, when you put smoke into the air, that's a good thing in terms of global warming. So when you see these pictures of smokestacks belching out smoke, actually those are the good ones, because that smoke is reflecting sunlight. It's the smokestacks that have been cleaned up, where the only thing going out of the smokestack is water vapor and CO2, both of which are invisible. Those are the bad ones. Now, do we want lots of smoke? No, because it causes health problems and other things. So we want to clean that up. But the interesting thing is, as the world is learning how to clean this up, this is causing the global warming constants to actually increase. Global warming is due mainly to human-produced CO2 production. 72% of CO2 comes from burning fossil fuels. And electricity and transportation contribute about equally. Actually, electricity generation, interestingly enough, produces a little bit more CO2 than all the cars and trucks. And again, if you don't think mathematically well, or you screw up the math, you can think, well, we don't want electric cars. If the electric utilities are producing more CO2 than the automobiles, why would you want electric cars? Well, you have to ask, how much electricity are they producing? Or is the electricity that is being produced right now, is that larger or smaller than the energy being required to propel vehicles? And this is a very interesting thing. The amount of electric energy produced per year in the United States, which is approximately 4 trillion kilowatt hours, is 5 times the energy required to propel all the vehicles in the United States. So I saw someone saying no, but if you compare it with calories or BTU of the energy input, the gasoline, no. But remember, the internal combustion engine is only 25% efficient. And you don't necessarily have to use an internal combustion engine to propel vehicles. The actual picture, when you have a vehicle, if you could pull it with a drawbar or a rope or something, what would be the energy transmitted through that line pulling the vehicle, where you have 100% conversion? And with electric vehicles, we don't have the inefficiency of an internal combustion engine. So when we deal with this and ask the question, if we had every vehicle as an electric vehicle, how much would we have to increase our generation? 20%, right? No, not even that much, because you don't plug cars in during peak hours. If you plug them in when you have available generation, turns out that by increasing our present generating capabilities by somewhere between 3 and 5%, every vehicle could be electrically powered. That's a really surprising thing. Now, I want to make it clear, the electric utilities are part of the solution, but presently they're also part of the problem. The distribution system is wonderful. It is 92% efficient. 92% of the energy generated at a generating plant gets transmitted over to an outlet. But just want to make sure I'm blinded by the light. I'm trying to see that I have time. Yes. Okay, good. So the electric utilities are very efficient for transmitting energy, and that's their good thing. They have 51% of the electricity being generated is coming from coal. And coal is probably the worst fuel. It is the worst fuel to use if you care about global warming. Coal is mainly carbon, not much hydrogen. So you take a carbon atom and you mix it, you react it with some oxygen, and you get CO2 directly and very little water. The best thing to burn is natural gas, because you've got a carbon atom and almost 4 hydrogens for each carbon. So there's much less per unit energy, much less CO2 produced when you burn natural gas. And oil is kind of in the middle. We're running out of oil, so the question is, do we go to natural gas or do we go to coal? We have more coal than natural gas, and the coal people would like for the answer to be more coal. And my feeling there is coal is fine so long as the CO2 is sequestered. Don't you dare call coal clean coal unless you sequester the CO2. And maybe we can get a movement going which forces the coal companies to not use the term clean coal until they sequester the CO2, until I'm troubled by that whole thing. Scientific predictions. With business as usual, CO2 could reach 960 parts per million by the year 2100. Remember, right now it's 380. We've gone from 270 to 380, and the future rise can be a whole lot more. And why is that? That's because a lot of the world is starting to do the dumb stuff that we're doing right now, using lots of energy to do things that may not need so much energy. The ocean levels could rise by as much as 23 feet if the Greenland ice sheet completely fails. A few years ago, this was considered impossible, and now people are seeing this as a real possibility. I think we have to keep in mind, though, that we have incomplete knowledge, especially when it comes to weather-related phenomena. We can't predict, what the weather will be like a week from now very well. And so understanding how global warming affects weather is a difficult thing. Predicting economic impacts is difficult. Keep in mind that in a few cases, global warming is going to be a good thing for some people. So understanding for whom it's bad and how much, all of these things are challenges to do right. And finally, I want to talk about people's beliefs with respect to global warming and also oil depletion as well. There's a lot of people that don't believe this. There are a lot of people, of course, that don't understand it, and many times those are the same. Many people feel that global warming is some sort of left-wing conspiracy aimed at hurting American industry. Interestingly, religion is part of the equation. I'm a Christian. A lot of Christian people feel that all of this global warming stuff is again, a left-wing thing. And I'm very